Good morning, dear friends. Today we are going to see pin retained amalgam restoration. So basically, pin retained amalgam restoration is a amalgam restoration in which pins are placed basically for retention purpose. So let us see the presentation. So as the name suggests, pin retained restoration means any restoration requiring placement of one or more pins in dentine to provide adequate resistance and retention form. Basically, it is a retention form rather than resistance form. If it is amalgam, it is pin retained amalgam restoration. If it is composite, it is called as pin retained composite restoration. So today we are going to see pin retained amalgam restoration. So why do we use pins? Pins basically we use because we want to increase the retention basically and to some extent resistance. Pins are indicated when the cavity is large. Suppose a small class 1 cavity, class 2 cavity, we can do a normal amalgam restoration. But when we want, when the cavity is large, we have to do a pin retained amalgam restoration. So what are the indications? To increase the retention form. Suppose the cavity is very large and the restoration cannot be retained inside the cavity that you are prepared. Then we have to use pins so that the restoration is going to be retained in the cavity. And status and prognosis of the tooth. A posterior tooth needing an extensive restoration and having questionable prognosis. I cannot give in this case a cast gold restoration because gold is expensive. So I don't know whether this tooth is going to survive or whether any other treatment will be needed. So as a holding restoration, I am going to use a pin retained restoration in this case. As a maintenance restoration and economy, when the patient cannot afford a gold restoration, also we go for pin retained restoration. When we want to complete it in one visit only time, and as a prophylactic restoration when poor oral hygiene is there, rampant caries is there. So in this case, we cannot give cast gold restoration. So we are going to use pin retained amalgam restoration. So what are the contraindications in pin retained amalgam restorations? So contraindications are badly broken down tooth that are symptomatic. When the tooth is badly broken down and is symptomatic, it means it has to undergo root canal treatment. So obviously you cannot do a restoration in this case. And when it is very badly broken down, then also always amalgam will take support from the tooth and gold will give support to the tooth. That is the basic thing. So very large cavity, again, you have to go for a cast gold restoration. And when the tooth is used as abutment in prosthodontics, you should not go for pin retained. Teeth requiring excessive occlusal alterations and aesthetic restoration. As you all know that the cast gold, the amalgam is black in color, so it cannot be used in aesthetic restorations. So what are the types of pins? There are mainly three different types of pins that are present: cemented pin, friction locked pin, and self-threading pin. As you can see here, cemented pin retains by use of a luting cement, whereas friction lock pin is gently tapped into position. Self-threading pin is basically threaded inside the pinhole. Self-threading pins were introduced by Boeing in 1966. 3 to 6 times more, they are more retentive as compared to any other types of pins. And the holes that you make are 0.0015 inch to 0.004 inch smaller than the pin diameter. 3 to 6 times more retentive than the cemented pins. Resiliency of dentine allow insertion of the threaded pin. Pin is retained by threads that are engaged in the dentine, and lateral and apical stresses are produced when you go for self-threading pins. The problem with self-threading pins is it cannot be used in an endodontically treated tooth because the tooth is already dry And if you use a self-threaded pin or a friction lock pin, then there is chances that the what you say the dentine is going to be fractured. So you have to use cemented pins in endodontically treated teeth. So next is self-threading pins. They are gently tapped into position and the pin holes are smaller than the pin diameter. Introduced by Markley in 1958, pin holes are 0.001 inch, larger than the diameter of the pin. The cemented pins are mainly cemented by zinc phosphate cement and zinc polycarboxylate cement, and they are the least, retentive. These are mainly used in endodontically treated teeth, that you have to remember. Then there is friction locked pins used by Goldstein in 1968, 0.001 inch smaller than the pin diameter. Pins are tapped in place gently and mainly resiliency of dentine. You cannot use this in endodontical treated. So, what are the advantages of pin retained amalgam restorations? Conservation of tooth structure, appointment time, and increase in retention and economics. Disadvantages are there may produce dentinal microfractures, there may be micro leakage, decrease in strength of amalgam, resistance form actually decreases when you use a pin retained amalgam. There may be perforations and tooth anatomy may not permit you to place the pins. So, what are the characteristics? What are the types, surface characteristics? How many pins you need? What are the numbers? What is the diameter? What should be the diameter of pin? All these things you should see. So, basic things will remain same. Okay, outline form, retention form, resistance form, convenience form, whatever you have studied in your fundamentals of cavity preparations, they remain same. So what we are going to see in this chapter is what type of pin you should use, that I have already told. If you want more retention, you have to use self-threading pin, friction lock pin. If it is an endodontically treated tooth, you have to use cemented pin. Now the question is how many pins we should use and what should be the surface characteristics of these pin retained amalgam restorations. So surface characteristics is the depth. A self-threading pin will have a corrugated surface, so more retention will be there. If it is smooth, then less retention will be there. Orientation, always when you place two pins, you can see here, they should be in non-parallel directions. They should always be in non-parallel direction. So if you want to change the direction of the pins, you have to use something called as TMS bending tool. With this kit of pin retained, you get a TMS bending tool. You have to use TMS bending tool to, bend these pins. Number of pins. How many pins you should place? That is the question. Now, the thing is, what is followed law is one pin per missing line angle. You have to use one pin per missing line angle. Say here, this line angle, you can see here, this line angle is gone, means the proximal box is extending buccally, and here proximal box is extending lingually, so that buccal proximal line angle is exposed and lingual proximal line angle is exposed. So two line angles are exposed, means you have to place two pins, one pin per missing line angle. What should be the diameter of pin? Usually the diameter is not decided by you. The company itself will give different diameters, that is regular, minim, minikin and minuta. So usually a smaller diameter sufficiently to retain the restoration in place, that should be used. And what should be the length? You can see here, when you place the pin, 2 mm it should be submerged inside the dentine and 2 mm it should be outside. So total 4 mm pin you will place, 2 mm inside the dentine and 2 mm outside the exposed part, which will retain the restoration. So TMS system is the system of pin that is widely used because of its versatility, wide-ranging pin sizes, color coding system, and great retentiveness. So regular is gold in color, self-shearing. Self-shearing pin means, what is self-shearing means? When you place the pin, see, first you have to make a pin hole of 2 mm. There will be a depth gauge, omni depth gauge. you have to make a pinhole, and then you are going to place the pin inside the hole. And once that a set torsional stresses come on the pin, then automatically it will shear off. It is called as self-shearing pin. Okay, it is called as self-shearing pin. Normally we use self-shearing pins. So these are the different sizes, and this is the. So before going into that, if we are able to see a video on pin retained amalgam, we will understand it better. So first, let us see the video. So this is the video of pin retained amalgam. You can see here. Here the caries is very, very large, as you can see. Here the caries is very, very large, as you can see. And as usual, the cavity is entered and then extended with a entered with a round burr, extended with a straight fissure burr. The cavity extensions are with a straight fissure burr. Now you can see that still there is undermining of the enamel over here. Still we have to remove the caries. So it has crossed the line angle, especially on the buccal side. See here the cavity proximal box has crossed the line angle already, and both sides it has crossed the line angle, whereas in this proximal box it has not crossed the line angle. So here two pins we have to place, one pin per missing line angle. So this is the drill, and these are the self-shearing pins. Self-shearing pins, and this is the drill. Okay. Now first we will make a hole with self-shearing pin drills. This is 2 millimeter only. Okay. Then we will place the pins. You can see magnified view of self-shearing pin. First we will make a pinhole in the dentine. So always when you make the pinhole, always remember that around the pinhole, when you place the pin, 0.5 mm space should be there, so that you can condense the amalgam. 0.5 mm space should be there for placement of amalgam. Always remember this. So pinholes are made there. You can see pinholes have been made. Now we can place the pins. Now we can place the pins. These are self-shearing pin. They will rotate, they go inside. Once the bottom is reached, automatically they will shear it off. Automatically they sheared off. So they are called as self-shearing pins. You can see here automatically they are sheared off. There it is, self-shearing pin. So once the pins are placed, they should be oriented in non-parallel direction. As I have told you, they should be oriented in non-parallel direction. And then we insert the amalgam. We insert the amalgam. And then we condense the amalgam first in the proximal cavity and then totally. It is our normal amalgam cavity condensation. So once we condense the amalgam, we overfill the amalgam cavity and then we do carving. As you all know, you have all done in second BDS. So this is basically a pin retained amalgam video example. Okay, this is a video example of pin retained amalgam. Right? Okay, so we will go back to our presentation. So these are the different. So clinical steps, patient education, initial cavity preparation. You have to evaluate the occlusal factors. You have to administer local anesthesia, apply rubber dam, perform initial cavity preparation, removal of infected dentine, pulp protection, and then placement of pins. So what is the amount of available dentine, amount of retention required? Then you will choose minikin, minimum different diameters of the pins. And then how many pins you have to place? One pin per missing line angle. Fewer pins, that is better. So location exactly at the line angle, always you should place your pins because that is where the most of the dentinal weight is concentrated. So line angles are the ideal places for placing the pins. And then how much deep you have to go? You have to go 2 millimeter deep, and 0.5 mm clearance should be there around the pin for condensing of the amalgam. That is very, very important, right? And pinhole is made 2 millimeter. Automatically it happens because the length of the burr that you use for pin retained amalgam is 2 millimeter, and then self-shearing pin automatically they go in 2 millimeter and shear off, right? So this is how you make it. Or you can make a pilot hole. Then after making pilot hole, you can use these depth limiting burrs. They are called as codex depth limiting burrs. So you can use these codex drills, and you can even check the depth of that hole by inserting the probe. It is an omni depth gauge. It is called as omni depth gauge. You can see. And different designs of pins are there which you can use for placing the pins. So for bending, as I have told you, if you want to make them in non-parallel, you can use TMS bending tool. TMS bending tool. And you can use Lenchulo spiral to coat it with cement, and then cemented pins can be done. Okay, then so different matrix systems can be used, like universal matrix, compound supported matrix, because basically cavity is very large over here. Since cavity is large, you need a circumferential band of metal. So different matrix systems are described here. So different matrix systems can be used, and we should know post-operative instructions as usual you have to give. And finishing and polishing can be completed after 24 hours. So along with that, in this chapter, what important thing you should know is how a pin retained amalgam fails, how it fails. So there may be a restoration fracture because there is no bulk. There may be pin restoration separation. There may be pin fracture, see, and then there may be pin dentine separation, and then there may be dentine fracture, and then there may be perforations, broken pins, broken drills, loose pins, and perforations. So these are all the different pin failures that you come across. So what we have seen today is pin retained amalgam, how the steps will remain same, in which cavity you have to do, what are the indications, contraindications, advantages, disadvantages, and what type of pin should be used, in which case, and what are the advantages, disadvantages, and what are the clinical steps that you should use, what are the clinical steps that are present for doing pin retained amalgam. See, it is same as amalgam, just like outline, retention, resistance, convenience, and all those things. Only thing is, once you prepare the cavity, you have to place the pins. Pins you have to place, and then rest of the things are remain same. So in this chapter, important is indication, contraindication, advantage, disadvantage. Then what different types of pins, advantage and disadvantage there, and in which situation what you are going to use, and matrix systems. What are the different matrices? Okay, thank you.